Okay, let's look at a couple of advanced examples. So really quick, remember how you would solve an equation like this, right? The goal is to undo all of the operations and just get x by itself. So what do? You add 2 to both sides, that'll undo the minus 2. And then so you get square root of x is equal to 3. And then how do you undo the operation on the x? Well, the opposite of square root is square. So you square both sides, and so now the square and the square root will cancel, and you just get x equals 9. So we want to apply the same type of thought process to this type of problem. So here we've got some continuous function, and it satisfies this property. So I know that x sine of x is equal to the integral from 0 to x squared of f of t dt, and the goal is to find f of 4. So I'm trying to get to the heart of that equation, which is f, right? I need to basically solve this thing for f and then plug in a 4. So the question is, how do I solve this thing for f? So you want to undo all of the noise around the f and just get f by itself. Okay, so we've got the fundamental theorem of calculus that will help us do that. So the question is, how do I get the function f by itself? So I need to undo the integral sign, and the fundamental theorem says I can undo the integral sign by taking a derivative. So let me take the derivative of both sides. So on this side, I'll need the product rule. It's the derivative of the first thing times the second. So sine of pi x plus the first thing times the derivative of the second. So that's going to be pi x cosine of pi x. And now that's going to be equal to, so now the derivative of this thing, well, the fundamental theorem says I replace t by x squared and then tack on the derivative of x squared. So this is f of x squared times 2x. So now I'm looking for f of 4. I've got a thing that says f of x squared. So what x should I plug in to get f of 4? Well, it looks like 2 will work. So now I'm going to let x equal 2. And so this tells me that sine of 2 pi plus 2 pi cosine of 2 pi is equal to 4 times f of 4. And so we're almost done now. So the sine of 2 pi, that's 0. And then the cosine of 2 pi is a 1. So I've got 2 pi is equal to 4 times f of 4. And so now that tells me that f of 4 is just pi over 2. So that would be a good final answer for this problem. So the moral of the story here is if you need to solve for f and you've got an integral sign in front of it, take derivatives. Like if you need to solve for x and you've got a square root around it, square both sides. All right, in this example, we want to compute this fancy limit here. But we'll see that these types of exercises aren't that bad. So first thing, we've got the integral from 3 to x, and then we've got x sine of t over t dt. So this is an integral with respect to t. That means that x is constant, and that means I can write it out in front of the integral. So this is the same thing as limit as x goes to 3, x times the integral from 3 to x sine of t over t dt all over x minus 3. And now if you like, if you just plug in a 3 for x, you get 3 times the integral from 3 to 3, that's 0, and then here I get a 0 in the bottom. So this is of the form 0 over 0. That means we're allowed to apply L'Hopital's rule. So let's do that. So this is the same thing as, according to L'Hopital, I'm going to take the derivative of the thing in the numerator. Right, so it's the derivative of the first thing times the second. All right, so the derivative of the first thing is 1 times the second thing, it's just this integral, plus the first thing times the derivative of the second thing. So x times, and now what's the derivative of the second thing? Well, according to the fundamental theorem, it's just cancel off the integral sign, replace t by x. So that's just sine x over x. And now the derivative of the thing in the bottom is just 1. So now I've got the limit as x approaches 3 of the integral from 3 to x of some function, and then plus x times sine of x over x. So you can cancel out the x's, and so you're just left with sine of x. So now, what's this thing going to be? So the limit as x approaches 3 of this thing, the integral from 3 to 3 is just 0. And so all of this just goes to 0. So that's this first piece. And now the limit as x approaches 3 of sine of x, well, that's just the sine of 3. So that would be a good final answer. So this is just the sine of 3. So we got that by L'Hopital's rule and the fundamental theorem of calculus.